Hello, welcome to another Algebra 1 lesson. This is lesson 6.3. Our objectives today: identify and evaluate exponential functions and graph exponential functions. Identifying and evaluating exponential functions. An exponential function is a non-linear function of the form y equals a times b to the x power, where a is not equal to 0, b is not equal to 1, and b has to be greater than 0. So it's just to make sure that if we simplify it, it's still going to be in this form where you have a number times another number to a power. As the independent variable x changes by a constant amount, the dependent variable y is multiplied by a constant factor, which means consecutive y values form a constant ratio. So if we are looking at a table of values and we want to know if it represents an exponential function, we will look at consecutive y values to see if they form a constant ratio. Does each table represent a linear or an exponential function? So the x's are 0, 1, 2, 3. Our y's go 2, 4, 6, 8. A constant ratio of the y's would mean that if we made a ratio out of two consecutive ones, like 8 over 6, then that would have to be the same as 6 over 4. And that would have to be the same as 4 over 2. Okay, 4 divided by 2 is 2. 6 over 4 is 3/2, and this is 4/3. So this is not exponential. Let's see if this one is. If I make a ratio of my y values, 32, 32 over 16, 16 over 8, and 8 over 4, are those all equal? They are. All three of those equal 2. So we have a common ratio. This is an exponential function. Another way to look at it, other than that common ratio, is to ask yourself, what do we do to get from this number to this number? So we're going to multiply by 2. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. There's that 2 showing up. What about this one? If we go 2 times 2, we get 4. 4 times 2 would be 8, not 6. Okay. What's another way we can go from this number to this number? That will work in each one of these situations. We can add 2, add 2, add 2. So when we add the same number every time to get to the next number, that is a linear function. So A was linear and B was exponential. It's always a good idea to check to make sure your x's change by the same number before you even start to compare the y's. That's an important part of the process. As x increases by 1, y increases by 2. The rate of change is constant, so the function is linear. That's a constant rate of change, but it's adding each time. Over here, b, as x increases by 1, y is multiplied by 2, so the function is exponential. So when you're multiplying by the same number each time, that means it's 2 to some power, because we're multiplying by 2 again and again and again and again. There might be some other number here for the entire equation, but because we're multiplying by 2 each time, it's 2 to a power. Exponential functions have x as an exponent. Evaluate each function for the given value of x, for example 2. So here's our function. Evaluate for when x equals 3. So replace x with a 3. Make sure to use the correct order of operations. Please excuse my dear Aunt Sally. Parentheses or other grouping symbols, exponents, then multiply and divide together from left to right, and add and subtract together from left to right. So it's really 1, 2, 3, 4 steps, because these are grouped together and these are grouped together. So nothing to do inside the parentheses. So then we go to exponents. 5 cubed is 5 times 5 times 5. 5 times 5 is 25. Times another 5 is 125. Now that we've done the exponent, now we can multiply and we get negative 250. Okay, example 2, part B. Do it again, but with a negative 2. Now, if you have a calculator handy, you can just use the calculator and type it in as you see it. 3 times parentheses 0.5 to the negative 2 power. Or you can do a reciprocal. It's a negative exponent, so that's the same as 1 over 0.5 squared. And then multiply these together. And we get 12. Okay, I could show more work. This was 3 times 1 over 0.25. So we get 3 over 0.25. And then you're doing 3 divided by 0.25. And when you do that, you get 12. All right, next example. Monitoring progress. Okay, these are the monitoring progress problems. So if you want to do the monitoring progress problems, they are in your textbook, your ebook. You go and open the ebook, the dynamic book, and go to the menu in the upper left corner of it, which is really a table of contents. Go to lesson 6.3, and you can choose a monitoring progress. But basically, just wanted you to think through a couple. Are these exponential or linear? Are we adding or subtracting to get to the next number? If we are, it's linear. Or are we multiplying or dividing to get to the next number by the same number? Then it's exponential. Okay, this one, we adding or subtracting. If we add or subtract to get to the next number, it's linear. If we multiply or divide to get to the next number, it's exponential. Because dividing by a number is the same as multiplying by the reciprocal, and subtracting a number is the same as adding its opposite. So that's why those go together. So we're dividing by 2 each time. This one's exponential. And this one, the x's increase by an equal amount each time. And these decrease by an equal amount each time. Those are linear. Because this would be -1, -1, -1. Next, 3 and 4. Evaluate the function when x equals -2, 0, and 1/2. Probably just want to get the hang of doing it on a calculator. There's a button. So I would do 2 parentheses 9 up to the -2 power. So you have to use this caret button, that up arrow, to get that exponent, and then press enter. And we get 0.25. Whoops. 0.025. Probably probably want to even organize these in the table. X is -2, 0, and 1/2. When I put in -2, I got 0.025. When I put in 0, anything to the 0 power is 1. So 2 times 9 to the 0 power is 2 times 1, that's 2. And then the 1/2 power, 9 to the 1/2. 1/2 power is really just a square root. Square root of 9 is 3, times 2 is 6. I think the main reason we have problems like this, we want you to either be able to do this by hand or at least be able to do it correctly on a calculator. And then here's another one you can try. Remember, you can check those by going to the ebook, and it'll show you more steps and the answer to this last one. Let's move on. Graphing exponential functions. Graphing y equals a times b to the x when b is greater than 0. If b is greater than 0, or sorry, b is greater than 1, it's going to go up to the right if a is positive. So that would be something like y equals 2 times 5 to the x. Something like that. It would go through here, and this would be the point 0a. If this is an invisible 1, it would be 0, 1. This is 2, this would be 0, 2. And if the a is negative, maybe it's something like -2 times 5 to the x. That negative flips that over. That's called a reflection over the x-axis. So those two equations I wrote up here in blue and red, the second one, the red one, is a reflection over the x-axis of the first one. And then here, graphing y equals a times b to the x when b is between 0 and 1. So something like 1/2 or 1/3 or 0.2 or 0.7, something like that. Then it's coming down. It's going down to the right when a is a positive number, and it's going up to the right. All of these approach y equals 0. They get really close to it, but don't touch it. It looks like it does, but it doesn't. Graph f of x equals 4 times 2 to the x power. Compare the graph to the graph of the parent function. Okay, so the parent function of this, we haven't talked about parent functions very much. The parent function of this would be 2 to the x. And let's call this p for parent function. If the parent function is 2 to the x, and our f of x is 4 times that, multiplying a function by a number gives us a vertical stretch by 4. To make our graph, we're going to make a table of numbers and graph our points. You can also go to Desmos. So we want to try at least one negative number, a 0, and at least one positive number. Okay, these are both positive, so it's definitely going to go up to the right. So it's going to kind of look like that. You put them in and you find your points. So using these numbers in the table one at a time, when x is -1, we are using this equation. 4 times 2 to the -1 power. 2 to the -1 power is 1/2. 1/2 of 4 is 2. 4 times 2 to the 0 power. Anything to the 0 power is 1, times 4 is 4. When x is 1, we put a 1 in for x. 2 to the first power is 2, times 4 is 8. And when x is 2, we get 2 squared is 4, times 4 is 16. Now we can graph them. -1, 2, 0, 4, 1, 8, and then 2, 16. Now, if we did a smaller number, this is going to, like the graphs that we saw previously, it's going to get really close to this x-axis, but not touch it. You can draw it just parallel to it, but just make sure you don't go below it when you're drawing your graph. All right, as we get better and better at these, we can memorize more of the patterns and get some shortcuts. But for now, your best way is to pick lots of x's and find the y's that go with them. And here's another one. A, b to the x when b is between 0 and 1. So that means you're taking a number like 1/2, multiply it by 1/2, it gets smaller, it'd be 1/4. Times a half again would be 1/8. So it's going to get smaller, 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 smaller. So it's going to be going down to the right. Oh, but it's negative. Let's see what that does. Is that going to flip this way? I think it is. So our A is negative, but our B is between 0 and 1. Let's go back and look at our notes. A is negative, B is between 0 and 1. A is negative, B is between 0 and 1. Okay, so it's going to look like this red one. This one. Gives us an idea of what the shape's going to be. Pick some numbers for x. Let's go, I want another negative one this time. -2, -1, 0, 1, 2. Okay, grab a calculator. You're doing negative and then 1/2. I would put in a 0.5. That's going to be easier to type. Negative 0.5 to a power. So you can just grab a calculator. Negative 0.5 up to the -2 power. Hit enter. Negative 0.5 up to the -1 power. Anything to the 0 power is 1, but we have that negative, so that's -1. Type it in and make sure. Negative 0.5 up to the 0 power. Oh, yep, it says -1. Negative 0.5 to the first power. And negative 0.5 to the second power. Oh, negative 0.5 up to the second power. Negative 0.25. Okay, put them on your graph. This is our x, y is in the sky. So think of y. If you get confused which one's x, which one's y, the word sky ends with y. Y is in the sky, so we put y in the sky. Y is up and down, x is side to side. So go over -2, so that's back 2, and then down 4. Back 1, 2, down 1, 2, 3, 4. Graph your points. And do not cross the x-axis. It gets really close to it. Notice these are getting smaller, 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 but they're not going to go to 0. And there's our graph. Okay, graphing. We've got a lot more going on now, and then they want us to describe the domain and range when we're done. Now, you may or may not have learned much about transformations last semester. So let me talk about transformations for a minute. H, K, and A all represent transformations. Think transformers, robots in disguise. Transformations is how did the graph or the function transform into something else. They use these letters, mathematicians, they use these letters H, K, and A for very specific things. H is a horizontal, notice I used H, horizontal translation, either left or right. K, not quite as obvious. K is a vertical, so if you say vertical, the C kind of sounds like a K, or K goes up and down. It's like flying a kite up and down. That represents a vertical translation. Translations are slides, slides around, up, down, right, left. And then that A value, A is always multiplication, and it gives you a vertical stretch or shrink by a factor of A. So the H gives you a horizontal translation, that's sliding left or right. K is a vertical translation, that's sliding, translations are slides up or down. Plus a number goes up, minus a number goes down. With the horizontal, X's always lie to you, like maybe ex-friends, ex-boyfriends, ex-girlfriends. They tend to lie to you. X's, things with the X's, they never do what we think they should do. If we do X minus a number, we'd like it to go backwards, but it doesn't. It goes forwards. So X minus a number is going to go to the right, and X plus a number will go to the left. But that's why the formula has an X minus H. It's a little tricky there. And then A is your vertical stretch or shrink by a factor of A. So when they tell us to describe the transformations, this would be a vertical stretch by a factor of 4. And a horizontal translation, this would be 3 units to the right, 2 units up, and a vertical stretch by 4 by a factor of 4. These are the transformations that were done to the basic parent function of 2 to the x. So now they've done 3 different things to it. So what we're going to do is we are going to see what that graph looks like on Desmos. Desmos, very helpful. Okay, I want to compare the 2 graphs without the 4 there at first. So I said it was going to go 3 to the right and 2 up. So if we take this graph of y equals 2 to the x, and we take this dot and we go 3 to the right, 1, 2, 3, and 2 units up, 1, 2. We get to this point right here, and that's a point on this new graph. But then they wanted us to also multiply it by 4. So then that changes things a little bit. It's a little harder to see those transformations of the graph. Now, on Desmos, we can also hit this little bar and make a table. And look at that. It'll give us these points. We can write these down and add them to our graph. So -2, 2 point something, so 2 and a little more. -1, 2.25, 0, 2.5, 1, 3, and 2, 4. And then draw our curve. Now, because it went up 2, it's going to approach this line, y equals 2, but it's not supposed to cross it, because before it got close to the x-axis, but we shifted everything up 2. So that's the equation y equals 2. So our range, y has to stay greater than 2. And our domain, we can use all the negatives, all the positives we want. That is all real numbers. Do you remember the symbol for all real numbers? You can do an R with a double line here, and that means all real numbers. So that's the other choice for writing all real numbers. So there's our domain, our range, and our graph. We did use Desmos.com to help us with this one. Transformations. Transformations are going to come up again before the end of the year, and you'll definitely learn a lot about transformations in Algebra 2. H is horizontal, K is vertical, and then when you multiply by a number, that gives you a stretch or a shrink. Response logs. Select from I made progress with, or tomorrow I need to find out, or right now I know. So use one of those sentence starters, write yourself a note, reflect on how it went today. Remember, you can watch this video again if you feel you need to, and this should help with your Big Ideas assignment 6.3. Thanks for watching. Have a great day.